Hi, Caleb with Brownhouse here, back again with Paul from FM Products, and as promised, we're going to be showing you what makes their products different, why they're better, what they're doing to just change the market overall. So I'm going to let Paul do all the technical speaking here and throw it on over. Paul?
Hey Caleb, I am so glad to have the opportunity to do this right now. My hair's standing up on my arms because this is this is a key thing that we don't get to communicate. You know, when guys look at a product description on a website, it's just like an ocean of text, and
Sure.
and nobody wants to read through all that. And a lot of the things that we've learned and put into these guns over the years isn't communicated. I'm very excited to be able to do this right now. But basically, what we have here on the table is a very simple operating system. When we did shows like Clash Splash or Red October or Lethal Weapons, we would have the operating system on the table, and all these AK guys would come by and look at it and immediately would have a sense of comfort around it because of the simplicity. So I'm going to start from the front and I'll work my way back. And basically, this is the operating system. We have a charging handle here. When we first were making this, we were machining this out of aluminum tube. You know, it's an economy of scale. As volume goes up, you're able to improve how you make things, and we went to an all-steel trolley for the charging handle. What makes this complicated to make is I have a hole here that is 4 inches deep and that this rod has to live in, and that hole has to be drilled straight. It requires a gun drill. So the old way we used to attach this charging handle is we would have a set screw on the front,
Right.
and it would come back and it would lock in a groove in the charging handle like that. And that was great. And when we were developing the Zukla for Brownells, believe it or not, we were doing T&E with James Yeager and, at his schools, and whenever a gun would go down, he would do our demo guns, and we got a lot of T&E from that. And the failure that we saw, the one failure we saw is one guy did a 5-day course, and on the 5th day, this screw came loose. So we put a second set screw in, which helped, but we always thought, well, what if we could make this part out of steel, and then we could use the other side as a locking mechanism as well. And so what we did is we have two grooves, one on the front and one on the rear, and then as we tighten this down, it locks it from the backside.
Okay.
So it's steel, you know, it's an upgrade over aluminum. We were really happy with that. Then we would move back to the carrier. The carrier has some unique features. One of those is we have a recoil lug on our gas key here. That recoil lug lives down in a pocket down into the carrier to distribute the load during recoil, and that was a really kind of ingenious thing we did, because what we found is we haven't really had any screws break like we'd traditionally see. Probably see that on 5.56 sometimes.
Right. Yep,
Probably
I've
done some
seen it.
videos on those too.
We have a video on our channel right now that is how to change an AR-15 gas key because of this exact reason.
Yeah, so we think that's an upgrade. You know, we're going to be taking the same technology and bringing it to our Gen 1. We call this a Gen 2, and we call a Gen 1 just a standard mil spec because we make both for people.
Right.
And we'll probably do this to our gas key at some point that we're currently making. We make a gas key, and we'll probably add this lug for our own guns.
Okay. Yeah.
Because it's going to be hard to change the market to do this. Although I believe this is an improvement, it's going to be some effort to get everyone to do it the
Right.
same way. So one of the things most people don't know is we have a firing pin spring. Super handy. This firing pin spring could be put on any AR-15 as a standalone product.
Okay.
So what we did is we made a custom extractor pin, and the extractor pin has some real estate in there for the spring to live. And the wonderful thing about the extractor pin is it's designed to fail and keep working. And so the cool thing about our extractor pin is it's captured by the carrier. So there's a little groove in the middle, and every 2,000-3,000 rounds you're going to want to replace that anyways. And so we give our customers 3 when they buy the gun. We usually give them 3 extractor pins. So it's good for about 6,000 rounds, and they take the tip of the firing pin, they push the extractor pin out, put a new one in, they're back and going. But it's designed that if it fails, it continues to function. We like redundancy.
Sure.
And so that's kind of what we did with this. We wanted redundancy. We have a round cam pin, and that really helps going in and out of battery. And the firing pin spring is a wonderful thing to have. You know, generally speaking, anytime you have an M4 and you drop the bolt, all that inertia will take the spring, will take the carrier into battery, and the firing pin will have enough inertia to give a little mark on the brass.
Right.
Just a common thing. And so with all this tolerance stack up over everyone making all these different parts, sometimes you might see an out of battery in a bad circumstance where a bad combination of parts are put together. And we'd like to mitigate those things with stuff like this.
Sure.
So then we have our recoil spring. Our recoil spring is a dual spring. It's nested and it's wound in opposite directions. We patented that. Like, the fact that that had never been patented really surprises me. But this is called a nested spring, and it's wound in opposite directions, so you don't get an enmeshment, or we don't get them stuck on each other.
Right.
And then you got your recoil rod, and the recoil rod goes through the as you push back on the charging handle, it compresses the spring. That's the simplicity of it. You have a rod and a tube with a hole in it. It's a very simple operating system with a lot less moving parts and a lot less to go wrong.
Yeah, and so for those of you who are looking at this right now and saying, why are those bolt carriers cut in half? It's because these are for the FM15 upper. Everything's contained in the upper. There's no buffer tube, any of that stuff. You don't need all that. Everything is contained right here. This is, like you said, this is the full operating system.
Right. We like simple is good. Like Glock, you can learn a lot from Glock.
Right.
You know what, I'm serious.
Agreed.
They did a lot of things right. We look as a firearm designer. I look at Glock and I learned a lot from them. Simplicity is key, right? You want it as simple as you can make it. You want redundancy. You want it simple. Another of the really cool things we did is how we make our barrel, and I'll just start from kind of front to back, and we'll talk about a couple things we did. We cut flats on the front, and that will fit a 1/2-inch box wrench, because that's one anyone will have. You know what I mean?
Yep.
And then that will help a guy put a wrench on it, support the barrel when they're installing a muzzle device. It's very difficult to know when you've hit 20, 30 pounds of torque when you're using a big guy using a mag pull wrench.
Sure.
And many times I've seen guys overcome the barrel extension, tightening the...
I've seen it.
Yeah.
Yep.
So this is just a kind of a way to do it a little differently, to give a guy to support this when they're putting on the muzzle device. This is a key thing. I used to run a barrel making plant. I've been making barrels for years. And one of the complaints we would get would be when barrel extensions would come loose over the years. So one of the things I looked at was, well, how can you tighten a barrel extension and get uniform torque? And the problem is, you'll take a 10 or 20-ton press and you'll clamp on something that's round. And the problem with that is it's going to want to spin, right? So then now you're holding something that's round and you're applying 150 pounds of torque. You never get true torque. So this was something where we wanted to ensure we were getting true torque. So we cut these 6 flats, 6 flats or 8 flats? 6. Anyways, it fits into a box wrench, right? We designed it to fit in a box wrench. So we cut a plate, a 1-inch thick plate, and we drop this down on a plate, and sure enough, we get 150 pounds of torque every time. Never had a barrel extension come loose. Like little things like that. Like this is an improvement to me.
Like once this is a standard AR barrel. Once once it's there, it's so obvious. Like, why?
Well, listen, you're a consumer too, right?
Right.
I mean, to me, the thing I struggle with is some people say, hey, that's not mil-spec, that's not mil-spec. Mil-spec is a definition of how you manufacture something, or what material to use, or how you coat it. It's how you do the process.
Sure.
This barrel is mil-spec, and I've made some improvements.
Yeah.
I'm going to call it an improvement. But
I would call it that, yeah.
Yeah. Some really cool stuff is what was the gas block. What most companies struggle with, I worked for manufacturers over the years, and they make a gun. And we found over the last 10 years, the quality of gas tubes varied more so than the previous 10 years, and you would see misalignments of gas tube, the hole for the gas to travel through on the gas tube. They'd be misaligned a little bit, or maybe there wouldn't be a perfect alignment between the hole in the gas port and the port in the gas block, and you would see some gas loss on some number of guns.
Right. And
so what companies would do is, if 1 in 10 guns wouldn't cycle, well, they'd open the gas ports on all of them. That's just manufacturing. You're always trying to chase the 10% or 5% or 1% of the guns that don't run. What are we going to do to make them all run? And that was just what people in North America did when they were making ARs.
Sure.
And that's why guns, for the most part, are overgassed.
Right.
They want the guns to run. Consumers want their guns to run, and the way you do that is you overgas it. So we really struggled to say is what's the least amount of gas we can use to make our gun run, because that'll pay dividends in recoil.
Right.
That feeling of recoil.
Yep.
So we did some things to ensure we got good gas seal. We drilled our gas port from the top. And the reason we drilled our gas port from the top instead of the bottom is I can physically go down and look in there, and I've installed the gas tube upside down as the first step to confirm that they're aligned.
Yeah.
So now I can take the punch out, I could flip it over, and now I could drive a pin through it, and I would know it would be aligned. Make sense? Because
Yep.
I just flipped it upside down. This is how we build the gun. We put this through the hole, and we confirm that it's aligned. And now I flip the gas tube upside down, and I put a pin through it. Now I know it's aligned.
Makes perfect sense.
So now we move on to the barrel, and this is where it gets fun. This is the final operation here. It's a machine surface. This is a qualification step, and if all these things don't go together at the final step and the pinholes don't align, I know I've done something wrong. So the way I've made this is a gauge also. So what you'll see is you'll see a little step here, and that little step is keyed so that it's aligned so that it will only go on one way. You mind if I bang it on the table?
Go for it.
Okay, sure. All right. And then you bang that bad boy on, and you can see the holes are aligned. Now I know I've got a very nice tight fit here, and now I'm gonna go, and I know everything's aligned because that machined feature, you can see perfectly aligns with all the parts.
Yeah. I mean, it goes together like Legos.
Like Legos, right?
People say the AR-15 is like Legos. It's
It
really not.
really
because
is. It really is.
It is, and it's not because there's so many different
Variables.
It's like if you had 20 different companies making Legos.
Yeah, that's a great analogy.
So have you ever tried to take like the knockoff Legos and attach them to the actual Legos?
No.
They don't quite stick just right.
Yeah, I got it.
So this is like actually using Legos on Legos.
Nice,
So
nice. We also double pin it. People say, why do you double pin it? I'm like, because I can, because why wouldn't you? Because look, we try to do three things. We try to care more about our products than our competitors. We try to care more about our consumers of our products than our competitors. And we try and care more about our partners than our competitors. I challenge anybody to care more about their product than us. I'm doing it right now. This is how I show I care. We need to get better at marketing our product, and the way we market our product is to get my product in people's hands.
Right.
And then you know what they do? They help us make it better. Everything you see here, a lot of this stuff was driven by feedback from consumers over the years. And these are the things that I wanted to put into the product when I could. So we got this great gas block. I'm gonna go ahead and bang this off. It might make a little noise. Sorry about that. And now we have a taper lock barrel nut. So we cut the taper on the barrel nut here, and we cut the taper on the barrel in the same machine. And so what we do is we were the first company to do that, by the way. A lot of people are talking about taper lock barrel nuts, but we started doing it about almost 3 years ago with you guys. With the Zukov rifle, the first one we did.
Yeah, awesome.
And we got a nice long barrel nut. And what that does is as you apply torque to it, it just naturally wants to align the barrel concentric, because you're distributing the torque across a large surface area, not this little tiny flange.
Yeah.
Right? So that really helped. We saw a noticeable improvement in accuracy. We were really pleased with how that turned out. And then there's one other thing.
Yeah, and before you get to that,
Okay.
I just want to comment on this a little bit. This is kind of the thing that blew my mind, was just taper locking this. So your standard AR-15 barrel, you already have a taper close to there anyway on pretty much every one of them.
Right.
And it's the stuff that you've thought of that was just already there, but no one was using. It just blows my mind.
Well, look, we help. I used to set up lines to make ARs, and I knew the problems that those companies struggled with, or AKs even for that matter. And that was always, we would build a gun, you'd have all this time and money into it, and then you go and test fire and then it doesn't run. You don't know until the gun is assembled there's something wrong.
Right.
And that's a very costly thing for position for a company to be in. So all of this stuff was me things like, how can we ensure through form and function and function testing before we go to the range that the gun will work? And it's helped a ton just to keep, because look, I don't care what company you are, every company makes mistakes. Every company employs human beings.
Sure.
It's the nature of it.
Right.
So, how can you introduce some controls that keep mistakes at a minimum? We really like the thought of that. Icing on the cake. This is amazing right here. I want to show this to you.
Yeah, let's talk about it.
If you buy an upper receiver from us, any upper receiver, if you buy a 102 upper receiver, which is our new 5.56 AK variant that we're offering through Brownells, or if you do the Gen 2, also Brownells, first company to pick it up. Thank you, Brownells. I'm saying it again. We have every upper comes with this. And what is that? That's a pick rail adapter. I really like supporting blue collar people. I know dollars are hard to come by now, much more so than ever. And what this allows people to do is we include this for the upper so that any guy with an existing AR can pull off that buffer tube, end plate, castle nut, all that stuff, and they can pop this on quite easily and have a bufferless design using their own lower receiver.
Yeah.
Lowest cost of entry for bufferless.
Yep.
Some cool stuff here. So, all this stuff's economy of scale. Again, like I said before, this was machined out of an aluminum tube. We went to steel. With this part here, we originally started with this piece out of plastic. Never really had any issues with it. It worked fine, but I always wanted to make this part out of aluminum. Now we're to the point we can. This is reverse threaded, so it's like suspension linkage. You actually reverse it you turn it in the reverse, and it draws the two pieces together. Okay? So as you unwind it, it pulls the pick rail into the lower. Pretty simple. But the cool thing is that you can just snap that right onto a 3/8" ratchet. You don't need any special tools.
Yeah, that's nice.
And then when you're done installing it, you take this little piece of urethane and you pop it into this hole, and now you've got something for the carrier to terminate against, right? One of the things we don't want to see people do is take our uppers and put it on their lower without giving it something for the carrier to terminate against. In other words, we don't want people to take it and not install this on their lower. That makes sense?
Yeah, that makes a ton of sense. And
Yeah.
I mean, you kind of gave a brief overview of this, but I'm looking at it, and there's some other cool features on this thing.
Yeah, there is.
So you have, obviously, like you said, it fits any standard lower, so 1 3/16 by 16 standard receiver extension threads. But then I flipped it around. Okay,
I forgot about that.
You have a slot for a QD.
Oh yeah, we like QD mounts.
Yeah, everybody likes QD mounts.
Yeah.
Not only that, but you have a set screw right there
I forgot about that, Caleb.
where your rear
I'm so
takedown
glad
pin
we're
goes.
doing. Yeah, but then you don't have to mess with all that. You do it at the end.
So you don't have to try and push your spring in and get
align
this to-
everything.
Yeah, you can just remove that set screw, install this, drop the spring in, drop the screw on top of it, and it's just that simple.
I forgot. You're right. That is. I take that for granted. I take those little things for granted.
Yeah, that's awesome.
Well, guess there's another thing you made me think about was this. This is held in. This can't come undone because of these grooves. Your buffer retainer keeps it from coming unscrewed.
Okay.
So your existing buffer retainer lives in one of these little grooves, and it guarantees it never comes loose.
Man, it's all self-locking. That's cool.
Yeah.
And it comes free.
Free. Well, it's included.
I mean, it's
It's free. It's included in the price.
I'll just say most other companies would charge extra for it.
Yeah. Yeah, look, selling. A lot of people say to us we should charge more. Maybe we should. Well, look, if you look at our competitors that do bufferless designs, we cost less than them.
Right.
And I do that for a reason. Like I'm trying to serve. My whole philosophy was that we want to serve blue collar people with our products and give them the best possible products they can get for the money.
Yeah.
Really hard to do.
It
really
is.
hard to do. To sell it for that and turn a profit is a real challenge. To care that much. You know what I mean?
Yeah.
Yeah.
I do.
I'm really proud of it. I mean, I can't make it better than we do. Even the barrel, like just simple things about the barrels, 41 V50. Nobody is vacuum stress relieving. Nobody does. It's incredibly expensive. It cost me $10 to vacuum stress relieve a barrel, every barrel. Just to vacuum stress relieve it. It's just a very expensive step.
So, tell us what vacuum stress relieving is, and then tell us why what that does versus a barrel that's not.
So if you're a barrel maker, you want to start. If you want to make the best possible barrel there's a lot of people selling barrel cells that will help you make barrels, and we make our own barrels, but we looked at how we were instructed to make barrels and had making barrels in the past. I'm like, how can we do it better? And that was my challenge to my team when we started doing this. And one of the things was material. We wanted to use 41 V50, which is what the military likes. It's harder, it lasts longer, it's has better thermal properties than 416. I mean, look, if the military wants it, if the people we're doing consulting with want it, then I want it. So it's what they perceive as the best. That's all they need to know. There's one company in North America that makes it. It's called Gerdau, and they make a aircraft grade and a barrel grade. Okay. And many people buy aircraft grade. You'll make a better barrel if you use barrel grade. And we take that blank and we do the traditional thing where we'll gun drill, ream, and button. Now we've gone to all this trouble to use the best material and use the best tools. Tools are consumable, and it costs me about $5 a barrel just in consumable tooling to really care to maintain the level of quality. In other words, to not overuse a tool, which is what people will always do because everything's driven by the dollar. So I have a very tight, restrictive limit on how many parts I can make, and then that part's taken out of those toolings taken out, and we replace it. So to care a lot, it costs me $5 a barrel just in consumable tooling. A gun drill can be resharpened, but really what I'm talking about is the reamer or the button. Those are really consumables.
Yep.
So now I've got this brilliant hole. I've gone to a lot of trouble. It's nice and shiny, and then I send it off to a heat treater, and now maybe they use they want to stress relieve it. What happens is, as you're buttoning it, you're imparting stresses into the material. And what they want to do is they want to relieve those stresses so that you don't get embrittlement. You don't want you don't want the barrel to break.
Sure.
And when you stress relieving it, it pulls all the stresses you've imparted into it by buttoning it. Because remember, when you're putting rifling, you're just basically pushing the metal out of the way.
Right.
You're forming it.
Yeah. Putting
all these forces into the metal. So then you would take this brilliant shiny part and you would send it out to somebody who would stress relieve it for you, and you'd get it back and you'd look down the board and it would be covered with scale. Scale is a thing that just happens with heat treating. So you've done everything right and you made this brilliant barrel, and now you turn the outside and then you send it off to QPQ and you're just coating over scale in the bore. It's a fact. And so we asked ourselves, how could we do it? So we looked around at the best processes. We found a place in the Pacific Northwest. TMT, shout out to you. You do good work. We did vacuum stress relieving. We get the barrels back. Bore's brilliant and shiny, perfect condition. Then we turn it. We turn the barrel, which I'd love you to come see our facility.
Yeah.
And then
we need to take a trip out there.
You should do it, yeah. Yeah.
We're bringing you guys with us when we go.
Yes, you too. Get good food too. Good food. You guys have good food here too.
Sure.
Yeah, it's all relative. It's all relative.
I'm from Louisiana.
So yeah, okay, never mind. Yeah, I take it all back.
Yeah,
they got real good food there. But we do little things like we use. We love automation at our shop. We love to automate, but there's certain areas that we don't rush, and chamber reaming is incredibly important to us. So that's a very dedicated job. It takes a skilled person. That's all he does. We use pure oil and we burnish the chamber. So it's a very laborious step. We headspace our barrel like 12 times during the process. Every single barrel is 100% inspected. Little things like we took. I'm gonna let the secret sauce out. So when we made a rack, we have this big cell that makes barrels, and we line the barrels up, and we have an air gauge there, and that air gauge will check the bore, it'll check the rifling, and it'll check everything for us. So we have two of them that we stack the barrels in a row, and we check the rifling on every barrel. We check every barrel, every inch of every barrel, and the reason we do that is we don't want to see taper at the ends. Taper is a common thing. With tapers where the bore, at the orifice exiting the barrel, that would kind of taper and you'd lose accuracy. The bullet would be unsupported at the end.
Right.
So we check 100% of every inch of every barrel, and we check the bore and the rifling, every inch of every barrel. We do 100% inspection on every barrel. We check every dimension on every barrel. We headspace the barrel 3 times, 4 times before we put it in the gun, and we headspace it again. My point is, it's very hard to communicate how much you care. You got to come see it
Yeah.
for yourself. You know, I want you to be skeptical, and I want you to see it for yourself.
All right, I'm gonna put on my hat of skepticism.
Yes. Paul saw it. Paul liked it too. So, yeah, we're really proud of it.
Awesome. And I want to go back to something you said earlier, real quick to touch on. For those of you who aren't aware, whenever he was talking about overusing a tool, tools are consumable. They wear out. Overusing is basically whenever a company is producing a product, they're using that tool. That tool's a little too worn out to be doing what it's doing, but they're still using it to save money. That's whenever you get, a decent barrel manufacturer that ends up with a lemon or something like that.
Right.
It's because they overused a tool, maybe.
Exactly right.
Usually it happens by mistake. They're not intentionally
Right.
overusing a tool. But if
It happens.
It happens.
Yeah.
And
What you find is making a barrel is you can do everything right for a number of years and then just make a couple bad barrels. It happens. It's really, really hard to make a barrel. And anybody doing it, I really have a lot of respect for. And, it's a very difficult thing to do right.
sure.
But you're right. So the way we track how many barrels, how many linear inches, because sometimes I make 16-inch barrels, sometimes I make 9-inch. So the only thing I track is linear inches on that tool. When it hurts a certain number, I switch it out. And look, we're known for a good barrel. We're the only manufacturer in the world to get one MOA out of a 9mm, and it's been documented repeatedly.
Man.
So we have a way we make our barrels that is. We patent a lot of stuff. Here's something interesting. We patent a lot of stuff, like hundreds and hundreds of patents. Like every year we have a full-time patent attorney. We patent everything. And some things we don't patent because it's an industry secret. If I were to patent how we do some things, it would become public knowledge and there would be no way to control if somebody else was doing it. That's called an industry secret.
Gotcha. Yeah.
So we have some industry secrets. And I'm pretty forthcoming about it. If you come by the shop, look, people can copy how we do what we do, but I doubt they'll copy how much we care. I challenge anyone to care more than us.
Okay. Yeah. And, we're gonna come by the shop and then we're gonna open up the tank of secret sauce.
Yeah, no, but we're happy to show you.
Spill.
Yeah, listen, I don't mind sharing people how we do things. I'm happy to do it. I honestly believe that it's like tasting good food.
Yeah.
You know what I mean? You knew the person that made that food. Like, food is very communicative. If you can taste love. You talked about food. Same thing with this. The way we've communicated this is we've gotten it in people's hands. We go to the shows, we take it apart. This is the only way we grew our brand, is just by getting it in people's hands.
Yeah, it's like going to a crawfish bowl. You look at it and you're like, I don't know if I'm down with that, but it's a whole.
It's a vibe.
I'm going to use that word again. It's a vibe.
It's a
whole
vibe. Yeah.
It's the same situation. So we'll need to do that. But Paul, man, I appreciate you coming out, showing us all this.
Hey, Caleb, this was a real long format video for us, but this is the key. This is a lot of stuff that I've spent years trying to communicate, and you helped me do it on film. Thank you so much for that.
Yeah, absolutely. Anytime. I was happy to do it. This is the last video. I'm just kidding. We got more videos coming. We're going to be taking a look at some of the complete uppers and lowers and go from there. So stay tuned, and we will see you in the next one.
Hey, Brownells, thanks. Let this kid come see our shop. I'm talking to you, Paul. Thanks, guys.